Today, inshallah, we will continue the topics of electrical transformer. Last class, we discussed the electrical transformer, what is the meaning of transformer, and why we need transformer in electrical grids. And we discussed the ideal transformer, and we agreed together for the ideal transformer. We neglect the resistance of windings, we neglect the reluctance of cores, okay, and we assume that there is no any leakage flux in the transformer itself. And we could find the relation of the voltage and the current with the turns ratio, which is nothing but the ratio between the number of turns of primary and secondary winding. Okay, and we could find that V1 divided V2 equal to N1 over N2 equal turns ratio. Today we will continue, inshallah. Let's discuss one important point in the transformer. Now, if we have in this circuit, we have transformer, assuming this is an ideal transformer, and this is the primary winding will be connected to the supply, and the secondary winding is connected to load. The impedance of the load is Z2. We refer here to number 2 because this is the secondary winding. So we have I2, V2, and the impedance connected to the secondary equals Z2. However, for the primary side, we refer all values or all parameters as ones. We have I1, the current of primary side, and the voltage on primary side is V1. Now, if the value of Z2 will be the same value seen by the supply at V1 or not? It's a question. Is the value of Z2 will have the same effect of the circuit if we move Z2 in the primary side?
لا دكتور المفروض لا.
It will be different, is it right?
Yes.
Because as you see, I2 is different to I1 because we have turns ratio N1 over N2. So it's expected also to have different impedance value. So we have actual impedance, which is the impedance at the secondary side, and we virtually will transfer this impedance to the primary side in order to get the effect of impedance on the primary side of the circuit. This is just virtual referring in order to make the calculations and circuit analysis. So if we said Z2, which means the impedance is both, or the exact impedance exists in the secondary winding, how we can get the equivalent impedance in primary? Simply we can calculate using the current and voltages. Here, Z2 can be calculated as V2 divided I2. And the impedance seen from the supply equal V1 divided I1. So simply we can say that Z1 equals V1 divided I1, and you can calculate V1 as the ratio or the corresponding value of turns ratio multiplied by V2, because we have V1 over V2 equals turns ratio, and I1 equals I2 over A. So simply from here we can say that Z1 equal to A squared multiplied by V2 over I2. And V2 over I2 equals Z2, so we can say A squared Z2. Now, if we refer Z2 to the primary side, the effective value will be A squared Z2. And we are going to give it a name of Z2 prime. Why Z2 prime? Because the impedance exists in the secondary side, so it's referred here by 2. And the prime because it's referred to primary. It's not at its actual place. So this is reflected impedance or referred impedance. not the exact place of the impedance itself. Is it clear يا شباب؟
Yes, doctor, but there is a question.
اتفضل.
This transformer is an ideal, right?
This is for ideal transformer now.
Okay, so this case only for ideal, not for not ideal.
No, just a moment. Transferring impedance for all of type of transformers. Okay? We are going to make the same for actual transformer.
But the question will be different because in the actual transformer, the ratio n isn't applied there.
In the actual transformer, we will consider the all of what we have neglected before, okay? And we can also transfer the impedance by the same way. Don't hurry, inshallah, we will discuss this maybe in the next week, Sunday or Tuesday.
Doctor.
Okay?
Okay.
Doctor.
Omar Magdi, you raise your hand. Omar Magdi.
By accident, doctor.
No problem. Okay,
Yes, I want to ask about A. What is A?
Khalid. A is the turns ratio, Khalid. We discussed it in the last class. A is the turns ratio, which is number of turns of primary divided by number of turns of secondary.
Secondary, okay. Thank you.
Okay.
دكتور.
Yes.
احنا بنقولها بس بنقولها برضه زد 1 بتكون موجوده ما تختفي.
Can you rephrase the question in English, please?
I mean when we transfer it on the other side, Z1 will be there still.
If you would like to transfer a quantity from primary side to secondary side, you have to do the same.
Yeah, but they both will be there.
Who will be there? Which both? You mean impedance and what?
Z2 dash and Z1.
Actually, there are no two impedance. It's only one impedance. Is it right?
Oh, okay.
So Z1 here means the impedance seen by the supply.
Oh, okay.
Which value of Z2 refer to primary. Okay. Okay. Now let's have an example for the transformer. Here we have a speaker of 9 ohms. So we have speaker has internal resistance of 9 ohm connected to a supply of 10 volt, and this supply has an internal resistance of 1 ohm. So simply we can say that we have two series resistances, 9 and 1 ohms, connected to supply of 10 volt, as you can see. The question is, derive the power absorbed by the speaker. What is the amount of power absorbed by this speaker? How we can calculate the شباب?
Should find I first. I1.
We need to find the current.
Then after calculating I,
multiply by R2. That's it.
Square I and multiply by.
You have the ratio of the turns, so we can find V2 and I2.
Sorry, again?
We have the ratio, so we can get I2 and V2.
Now we don't have transformer. We just explain this circuit, just simple circuit. Two resistances connected in series with supply. Okay.
We find I can find the power at R2.
Right. So we can just multiply square of current by the value of resistance. This is all. So simply we can say that I equal to 10 divided by summation of resistances. So 10 over 10 equals 1 ampere. So the resistance now is 9 ohms. So the power will be I square R, which is 9 watts. So without transformation, the power absorbed is 9 watts. تفضل.
How you determine the current, doctor?
You have two series resistances. Use Kirchhoff voltage law. So 10 equals 1 plus 9 multiplied by current. تمام؟
Okay.
Okay. Now, to maximize the power transfer to the speaker, a transformer of 1 to 3 turns ratio is used between source and speaker, as shown in figure B. So we insert a transformer between the supply and the speaker. This turns ratio of the transformer is 1/3. So this is N1 divided into value. What's required here? Calculate the same power absorbed by the speaker. So what we can do, Shabab, now?
We find the current and the after the transformer I2.
How we can find the current after transformer, Faisal?
By the relation of A, 1/3.
You have the relation, you know N1 and N2. Is I2 or I1 given?
No, we should find Z1. Or
We should get the reflected impedance first. Is it right?
yes.
جميل. So Abdurrahman Ahmed, Abdurrahim Ahmed. Abdurrahim with us?
Yes.
Can you answer me? How we can calculate the reflected impedance?
Through the ratio, turns ratio.
So what will be the value? You have 9 ohms now in the secondary side. What is the effective or reflected value to primary side?
I'm not sure.
Be active with us, please. Ahmed Saeed.
Yes.
Can you tell us how we can calculate the reflected impedance? What will be the value of Z2 prime?
Yes, we take the value of the other side of the impedance.
It's 9 ohms. So what will be the value now?
I'm not sure about value.
Please be active يا شباب يعني. حسين عادل Bashir.
Yes.
Yes. How we can calculate the reflected impedance, Hussein?
We take the ratio and square it and multiply it by the reflected impedance.
What is the value of reflected impedance now?
9 multiplied by 1/3 square will give us 1.
Exactly. So the reflected impedance now, Shabab, will be 1 ohms. Type. If we have 1 ohms from the speaker and we have another series 1 ohms from the supply, so what is the total resistance now?
2 ohm.
Total resistance is 2 ohms. So what is the value of current?
10/2.
10/2 equals 5 amps. This is right. So 5 amps instead of 1 amp for the previous case. Now the power can be calculated as P equal I square R. So simply, as you can see here, this is now the value of current, 5 amps, and the power can be calculated as I square, 25, multiplied by R, which is the reflected resistance, which is 1 ohms. So this is 25 watts. We can calculate this refer to secondary as well. How? Just calculating the secondary current based on the actual primary current. So we have I1 divided I2 equal 1 divided A, which is 3 here. So I2 equal I1/3. So the reflected current to the secondary side will be 5/3 ampere. Simply, we can say that the resistance of 9 ohms multiplied by I square will give you the same value of power, which is 25 watts. So this is just brief example to show you how we can make the reflected impedance and also to show what is the effect of adding transformer for the power. يا شباب. Now, you know the flux direction in the core depends on the way you already make the winding around the core. If you wound the core in one direction, so you will have a certain direction for flux. However, if you reverse the direction of winding, the flux will be reversed. For that, for all of transformers, because the transformers are already wound and you are using it without any winding, you have to use transformer ready. So it's already wounded and there is internal sign to know the direction of winding. However, you cannot enter or have access to the core from inside the transformer. So we have to make something to understand or know the flux direction. Firstly, we have a rule to identify the flux direction, which is called polarity rule. What is this rule? Simply, if you have a flux, a winding here, winding number 1, 2, and 3, 4 for this transformer, and simply, as you can see, based on the Maxwell right-hand rule, you can find the flux direction. So here, the flux direction related to coil number 1 is going to move in this direction based on Maxwell right-hand rule. And similarly, if we apply the same rule for the other coil, you will find the flux is moving in the same direction. So this means the coil, which is energized by positive at terminal number 3 and the positive at terminal number 1, these two terminals are identical. So we can add a sign here, which is dot. This dot will represent that these two terminals are identical, which means if you supply the current from these two terminals, you will have aiding flux. Otherwise, if you reverse the polarity, the flux will be the difference between the two coils fluxes. Is it clear يا شباب؟ Right. So how we can get the polarity or know the polarity without accessing the transformer? We can make a simple test. Just have a transformer like that, and as you can see here, this is considered as the primary winding, and here is the secondary winding, and the terminals of the primary winding is 1, 2 terminals. This is the 2 terminals of the primary winding, 1 and 2, and 3 and 4 are the 2 terminals of the secondary winding. If we connect terminal number 2 to terminal number 4 and use 3 voltmeters, as you can see, 1 voltmeter at the supply side of primary winding and the other at the output side of the secondary winding, and another another voltmeter between terminals 1 and 3. Now, if the reading of this voltmeter equals the summation of the 2 voltmeters, this means that the 0.1 is identical to 0.4. Why? If you apply Kirchhoff voltage law now, you can find that this terminal is positive, this is negative, and when you move in the same direction, you will find positive, negative. So if the result of voltmeter 1, 3 equals sum of the 2 readings of the other voltmeters, this means this assumption of polarity is right, which means 0.4 or terminal 4 is positive and terminal 1 is positive as well. So 1 and 4 are identical. If you would like to add dot now for this connection, simply you can add the dots like that. This point is identical to that point. Okay, شباب. So this is the way of identify the flux direction and the polarity of the coils. Why we need to understand the polarity? This is very important to connect transformers in parallel. Now the question, why we need to connect transformers in parallel? We agreed together before, we used the transformers in cascaded in our network in order to stepping up or stepping down in the voltage. However, why we need to connect transformers in parallel?
For the voltage, doctor, to have similar voltages.
Having similar voltage is essential to connect them in parallel. And we cannot connect transformers in parallel if the voltage levels of the two transformers are different. However, why we need to connect them in parallel? شباب, why we need to connect the transformers in parallel? Can you imagine?
Maybe to provide power for many devices.
Exactly, to provide more power. And if you have certain power and you don't have the same transformer rating, you can use two transformers in parallel. This is number one. Another reason is the continuity. What's the meaning of continuity? We have some loads which are critical loads. Okay, these loads, the supply interruption is prevented or not allowed to interrupt supply to these loads. Okay, so in order to keep the supply continuous, we add transformers in parallel. If one of the transformers is not functioning and has any problem, any fault, the parallel transformer can start working. Okay, شباب? So this is a matter of protection and in order to keep the load continuously supplied. Okay, so this is the reason why we may need two transformers to be connected in parallel. طيب, how we can connect transformers in parallel for single phase one? Now we are discussing the single phase transformer. As you can see, the left hand, تفضل.
النقاط يا دكتور كيف نحدد مكانها فوق وتحت ما دام ايدنتيكال ليش ما تكون في نفس المكان؟
You ask about the polarity.
The polarity, yes.
Yes.
Why we don't have this one, the last one?
Here, in this slide or next slide, you mean?
Next slide, yes. Yes.
Okay, fine. Based on our test, again, I will discuss the test again. We have this transformer, okay, and we supply the primary winding by a certain amount of volt and measure the voltage using 3 voltmeters, as you can see, one for terminals 1, 2, another one for terminals 3, 4, and the third one is between terminal 1 and 3. Again, if we apply Kirchhoff voltage law from point 1 to point 3, like that, we will start from here in this direction. Okay. تمام. Okay. So taking the loop, start from point 2 and return to point 4. Where 2 and 4 are the same points now. تمام. You will find that here you crossed V12 or E12 and moving here E43. Okay, so if the value of E12 plus E43 equals the value of E13, which is this voltage, so in this case your assumption of the polarity is right. What is the meaning if the assumption is right? The meaning is point 4 is positive and point 1 is positive as well. So 1 and 4 are identical. This means you have to add the point at terminal number 1 here and at terminal number 4. Okay, So if we return back now to the dot coils here, you can add the dots like that. Okay? So what will happen if the reading of the voltmeter is the difference, not the summation of the values? This means your assumption was not right, and point number 3 should be positive. In that case, point number 3 will be identical to point number 1.
Okay, clear.
Okay?
Yeah.
Is it clear now?
Yes, thank you.
Welcome. If we have two transformers now and we need to connect them in parallel, firstly, you have to use identical transformers, which means the primary voltage is the same level, the number of turns and turns ratio are the same. And you cannot connect two transformers with different voltage levels. It's not allowed to connect any supply in parallel or any source in parallel with different voltage values. So, firstly, you have to be sure about the voltage levels and the number of turns or turns ratio. If these values are equivalent or identical, so you can connect them in parallel. طب how we can connect in parallel يا شباب? Simply use the dots. So for transformer number 1, you can connect the dot coils together. So this is a dotted coil, and here is the dotted coil. So these 2 points can be connected in parallel. Similarly, for the secondary side, this is a dot and this is a dot, so you can connect these 2 terminals in parallel. تمام كده يا شباب؟ This is for the right connection. What will happen if we reverse the connection? Simply, can you see here, we connected the primary in the right way. However, the secondary is not connected properly. So this means you will have extra voltage because, as you can see, this is positive, negative, connected here to positive, negative. This means the secondary voltage will be added together. So you will have higher voltage. This may damage the load and makes very high current in the circuit. So this is not right. Okay, شباب? So you cannot connect these transformers in that way. It's very dangerous to the load. Okay? Right. So this is now the right connection using the dot coils. For three-phase transformers, we have extra conditions. Not only these simple conditions, we will have some other conditions like the phase sequence, okay? And also we need to check something else called the phase shift. Okay, we are going to discuss this in details, inshallah, for the upcoming classes, inshallah, for three-phase transformer and generator as well. Okay. Now, we discussed the ideal transformer. What is the difference between ideal and the practical one? Simply, we didn't consider the resistance in the ideal transformer. So if we consider the resistance of the ideal transformer, you will have resistance like R1 here now. And the same is also for the secondary side, R2. Also, we consider that there is no magnetic leakage flux. However, in actual transformers, sure, you will have some leakage flux. And this leakage flux here, like as you can see, which is the flux moving here in the air gap. We call it here as phi L1 and for coil 2 as phi L2. So we will have some leakage flux for the transformer, for the practical transformer. Another, this leakage flux will contribute a leakage inductance, okay, for the primary and secondary winding, and simply can be calculated as L1 and L2. As you can see, L1 equal N1 phi L1 divide I1, and L2 equal N2 phi L2 divide I2. And these are the relations which has been described before in the magnetic circuits. Right. So we have now XL1, which is the leakage reactance of primary side windings, and we have XL2, which is the leakage reactance of secondary side of the transformer. Another important parameter, which is the current that is used to establish the flux in the transformer. Now, when you operate the transformer, you need to have sum of energy or amount of energy in order to establish a flux in this transformer. This value is small. However, if you consider practical transformer, you have to take it in account. For that, we can make a branch in parallel with the R and X. Okay, sorry, after R and X, like that here, in parallel with this core, in order to represent this leakage in current. Okay, so if we now have, this is a primary winding and this is the secondary winding, and we have another branch here in parallel, which represents the magnetizing reactance, because we have some current which is used to establish the flux in the transformer. Also, we referred before to some losses in transformer in the core, which is the eddy current loss and hysteresis loss. And you know, for any kind of power, we can represent this power by I square R. So simply also we can represent the core losses by a resistance here in parallel like that, which is going to take sum of current, and the I square R, IC1 square multiplied by RC1 will be equivalent to the core losses of the transformer. So in order to emulate the practical transformer, we have primary winding of R1 and XL1. We have magnetic core equivalent circuit, which is RC1 in parallel with XM1. And we have secondary side winding values, which are R2 and XL2. And in between here, this is considered as the isolation, which is represented by the ideal transformer. And this ratio of the transformer is N1 over N2. So in order to calculate everything referred to one side, we need to reflect the impedance here. We need to reflect the load impedance and the values of I2 and E2 as well. So we need to reflect all of these values, E, I, V, R, X. We need to reflect all of these values to the primary side. Simply, we can use the relation of voltage, current, and impedance with the Turner's ratio. So simply, for R2 prime, which is the equivalent resistance of secondary referred to primary side, equals R2 multiplied by A squared. Similarly, X2 prime equal to X2 multiplied by A squared. For the EMF, E2 prime equals E2 multiplied by A, which is equal to E1. For V2 prime equal to V2 multiplied by Turner's ratio. However, the current is the reverse, so I2 prime equal to I2 over the Turner's ratio. تمام شباب؟ So we just referred all of the parameters, resistance, reactance, voltage, current, from the secondary side to the primary side. So all of parameters that have prime, X prime, R prime, V prime, I prime, all of these means these values are referred to prime. تمام يا شباب؟ Is it clear? جميل. So this is now the equivalent circuit referred to primary side. Now, can we make some assumptions to simplify the solution of the problems? Simply, let's return back to the previous circuit here. شباب, if we have impedance Z2 with definite value, okay, and you know the values of R and X for all of this problem, and it's required to calculate the power absorbed by the load Z2 prime. How we can do that? Let's open a discussion together. How we can calculate the power consumed by the load Z2 or Z2 prime.
دكتور Z2 prime
Sorry? Your question again, please.
تفضل في واحد ثاني.
شباب مين اللي سأل Z2 prime ايه؟ شباب is there a question؟
كنت دكتور بقول انه جست بس احس انه في المايك بيتداخل الصوت انا عشان كذا وقفت.
لا ما فيش حد طلب السؤال يعني you can continue.
So what we can calculate the current that flow to the needed load. So we can
how we can calculate I2 prime now?
We take the RC1 and the inductor and we take the equivalent of them and then we find the current by the Kirchhoff current law.
So you can get the equivalent impedance of the whole circuit.
Yes.
And after that, get the value of I1 and then use current divider rule to get the value of I2 prime.
Exactly.
This is one way. However, you can use simply the circuit analysis like Kirchhoff, like loop. Is it right?
Yeah, we can do that also.
So you can make one loop or two loops. And we can equivalent of RC and XM instead of parallel to be series impedance. Okay. In that case, you will have only two loops. And you can solve the two loops together in order to get the value of I2 and calculate the power loss. تمام؟ طيب. Can we make more simple circuits in order to يعني simplify the analysis? Is it possible يا شباب to make يعني more simpler circuits?
Yes.
Let's see the values of R1 and X1. يعني normally these values are very, very small. So when we solve problems, inshallah, you will find these values are very, very small. So we can say that the voltage drop across R1 plus JX1 is very small and leads to zero. If it leads to zero, so we can assume that V1 equal this voltage. Is it right?
Yeah, but doctor, you assumed this assumption because they are internal resistor or internal loads.
I assume the values of R1 and X1 to be small.
Do you Sorry? This is what?
I assume the voltage drop across R1 and X1 very small value. This because the current absorbed here I phi 1, which is the no load current, is very, very small. Yani this current maximum can be around 5% of the input current.
But I mean, you take this assumption based on what?
Based on two things. First, the voltage drop across the impedance here is very small. The second, the current which is moving here in this branch is very small. So this we can move value. Can you hear me يا شباب?
Yeah, but why you know this is very small current يعني على كيف حكمت هذا اللي أقصد.
Based on what I'm discussing now, the no load current is maximum for transformer is maximum 5% of the full load current. Okay, this is due to the losses or the amount of current needed to establish flux in transformer is very small. Okay, يعني maximum 5%. This is number one. Number two, because the impedance R1 and X1 are very small, and you will see in the problems the numbers or real numbers of R1 and X1, you will find that the voltage drop across these values are very small. So we can assume that we can move the value of R1 plus JX1 from this side to that side. So we can assume the circuit to be like that. We have R equivalent and X equivalent, which are R1 plus R2 prime and X1 plus X2 prime. So this is now the equivalent impedance of the two windings. And here is I1, and this is I2 moving in all of the windings. So in this case, you can make only one loop because the voltage here will be V1, and simply you can calculate I2 prime as V1 divided by this impedance, the impedance of the winding plus the load impedance. Okay, Shabab, is it clear now? Is there any question regarding this assumption? So this is the first approximation. We may have another approximation. Now we describe that the current which is moving here in this branch is very small. So why not removing all of the branch from the circuit? So simply we can assume that there is no any magnetization current because it's very small. So this is another assumption. So we can assume that the equivalent circuit to be like that, just one impedance, which is the equivalent impedance of the both windings, and here is V1 and V2 prime. And in this case, we will assume that I2 prime and I1 are the same. So this is the second or approximated equivalent circuit. We will see how to use any equivalent circuit in our problems, inshallah. But for now, just we need to understand we have two different approximated equivalent circuits. تفضل يا جون.
الآن احنا قلنا انه R1 و X1 very small.
Yes.
طب ليش نقلناها الجهة الثانية؟ ما كان أفضل لو شلناها من السيركت؟
if you neglect from the circuit, you will neglect many things. However, if you just neglect the voltage drop, you will consider many other things like copper loss, because we have something very important in the analysis, which is the copper loss of the transformer. So we try to simplify as possible. However, there are some basics we cannot neglect, like the resistance itself, okay, like the core loss. Here, although we already removed the branch of R core from the circuit, however, in power calculation we have to consider R core. It will be considered in a different way. If we have, or if we need to calculate the core loss for a transformer, we cannot use this circuit. Okay?
But doctor, the calculation will not be accurate.
Sorry?
The calculation will not be accurate.
Exactly, it's approximated. The accurate one will be obtained from the exact one.
Okay.
However, sometimes you may need the approximation. You don't need to find the exact value. As an engineer in sites, in particular the field, you need to make very fast decisions. For this decision, you cannot take the paper and your pen and start solving problems. No, you need very simple calculation to take the decision. For that, you can use the approximation. تمام. However, if you need to calculate the exact solution, so you should use the exact equivalent circuit. Okay يا شباب? Is it clear?
Yeah, clear.
Inshallah, next class we will start solving some problems on the this equivalent circuits and on single phase transformer. Any question يا شباب?
Yes, doctor.